In this video, I will show you how to solve exponential equations such as these. For number 27, the bases are already equal, so I'm just going to set the exponents equal to each other. So that's going to give me 2m is equal to negative m. It's tempting to divide both sides by m, but we can't do that because m might be 0 and you can't divide by 0. So instead, we are going to add m to both sides. So that's going to give me 3m is equal to 0. And then we will divide both sides by 3. And that will give me m is equal to 0. So that must be the answer. For number 28, we'll have to actually, I changed my mind. Both of these can be written in terms of base 6, so that's probably the easiest approach. So I could have 6 to the 2r power, and this would be the same thing as 6 squared. So those exponents must be equal. So 2r must equal 2, and r must equal 1. Alright, number 29 looks a little bit strange because of all the fractions. But remember that 8 is 2 to the third power. So just think of it that way. So for the first fraction, 1/2 is the same thing as 2 to the negative 1 power. And so 1 over 2 to the third power is the same thing as 2 to the negative 3 power. Now, we'll have to take the exponent that's already there and put it in parentheses. So I have a 3x minus 1 in parentheses, and I have negative 3x in parentheses. So look, the exponents are going to be equal to each other. So I'm going to ignore the bases and just set the exponents equal to each other now. I'm going to go ahead and do the distributive property as well. So this is going to give me negative 3x plus 1 is equal to, and this will be 9x. Let's go ahead and add 3x to both sides. So that's going to give me 1 is equal to 12x. And then just divide both sides by 12. So x equals 1/12. Number 30, both of these can be written as base 6. Okay, you will have access to a chart like this one. So notice that 216 is 6 to the third power. So I could write this as 6 to the third power. And of course 36 is 6 squared. And then you have to take the exponent that's already there and put it in parentheses. Now the exponents will be equal to each other, so I'm just going to set the exponents equal after doing the distributive properties. So 3 minus 6n is equal to 2. Subtracting 3 from both sides gives me negative 6n is equal to negative 1. Dividing both sides by negative 6, I have n is equal to 1/6. So that should be the final answer for number 30. Okay, for number 31, looking at 16 and 32, I would love to write these both using the same base. Maybe I can. Looking at the chart, it's all about finding a row that has 16 and 32 in the same row. And it's right here in row 2. 16 is 2 to the 4th power, and 32 is 2 to the 5th power. Okay, so I can rewrite this as 2 to the 4th power, and that b will still be there. And 32 is 2 to the 5th power. Of course, now that means the exponents will be the same. So 4b should equal 5. So b is equal to 5/4. So that will be the final answer for number 31. All right, let's solve Number 32. There are at least 3 ways of solving this I can think of off the top of my head. But see how there's only variables on the ones on the left side, not both sides? When it's like this, the easiest thing to do is just rewrite it in log form. As opposed to doing the log of both sides, that won't be necessary. So we could just do log form. So this would be log, the 10 is understood, but log base 10 of 7 is equal to negative 9x. Of course, we don't write the base 10, so I'm just going to say log 7 is equal to negative 9x. This is the quickest way. And then just divide both sides by negative 9. And you're done. That's really all there is to it. Now you would get the same answer if you did like the log of both sides or something, but this is by far the quickest. Boom, done. All right, let us solve this exponential equation as best we can. There's no algebra 1 stuff that we can do, so I'm going to go straight to changing this to log form. So normally I would go log, and then I would put the base, and then I would switch the other stuff. So that would be log base 10, and the 7 would go over here, and the negative 9x would go over there. But that's silly because we're not supposed to write base 10. So this is really log 7 is equal to negative 9x. Dividing both sides by negative 9, that's going to give me x is equal to log 7 over negative 9. That's it. That's going to be the final answer.
Wait, can you
All right, let's solve this equation for A. First, we're going to take care of the algebra 1 stuff. So let's divide both sides by negative 2. So that's going to give me 8 to the A plus 5 power is equal to 11. That's as far as I can do with the algebra 1. Time to rewrite this in log form. So this would be log base 8 of 11 is equal to A plus 5. And then all I have to do is subtract 5 from both sides. So I will get log base 8 of 11 minus 5 is equal to A. And that's all we can do. Problem number 34. To solve this, we will first do our algebra 1 steps. So I'm going to definitely add 6 to both sides. So that will give me 10 to the negative 8x minus 2 power is equal to 81. Well, that's all the algebra 1 I can do. So now it's time to rewrite this in the other form. If I were just blindly doing this, I would write log base 10, because I always bring the base down. And then everything else changes sides. So the 81 would come over here, and the negative 8x minus 2 would go over there. But we're not supposed to write base 10, so I'm going to erase that. All right, the 10 is understood, so I'll just write log 81. So now I just have to get x by itself. So the rest of this is algebra 1. So I'm going to add 2 to both sides. So that gives me log 81 plus 2. Don't add these numbers together and get 83. That's a big mistake kids make. All right, this 81 is like inside. Anyway, so that's equals negative 8x. And then the last step is to divide both sides by the negative 8. Okay, and that's really going to give you the final answer of x equals log 81 plus 2 over negative 8. For number 35, we just have a log equal to a log. So the stuff inside the log should be equal. So 3x plus 10 should equal 3 minus 5x. All right, that's called the argument of the function. So the arguments should be equal in this case. Let's just add 5x to both sides. So that's going to give me 8x plus 10 is equal to 3. And then if you subtract 10 from both sides, that gives you 8x is equal to negative 7. And then if you divide both sides by 8, you get negative 7/8. So that should be answer to number 35. 36 is the exact same thing. So negative r plus 6 should, wait, hold on, let me go back. We should always stop and check to see if it's extraneous or not. You can't take the log of a negative number, so we just have to make sure we're not getting a negative number. Let's see, 7/8. Okay. This is something, it's about, it's 0.875. So remember that. So I need to check out and see what happens if I do 3 minus 5 times 0.875. Didn't write that correctly. Okay, so let's see what happens. If we do 3 minus 5 times 0.875, that's going to be a negative number. So that means this is actually extraneous, which means there's no solution. Okay, so always check that. So on the next problem, negative r plus 6 is going to equal to negative 3r plus 6. Let's add 3r to both sides. So that'll give me 2r plus 6 is equal to 6. If we subtract 0 from both sides, if we subtract 6 from both sides, we get 0. So that means r is equal to 0. Now you can't take the log of 0. Does that mean that this is automatically extraneous? Well, not necessarily. If we plug in 0 right here, for example, we still have 6. So that's okay. And it's the same thing over here. If I plug in 0 right here, this term is gone, but we still have 6. So the solution r equals 0 is valid. It's not extraneous. Okay, so take a look at number 37. It's very similar. The argument should be equal. So 9k plus 3 should equal k squared plus 3. I see the k squared. This is quadratic. So probably we're going to end up factoring. Worst case scenario, quadratic formula. But let's get 0 on one side. If I subtract 9k from both sides, and if I subtract 3 from both sides, I'm going to wind up with 0 equals k squared minus 9k. The 3's cancel out. So I need to factor this, but it's really just a GCF situation. So k times k minus 9. Setting each of these equal to 0, that gives me k equals 0, and it gives me k minus 9 equals 0, or k equals 9. So these are the two potential solutions, 0 and 9. I just need to make sure that neither one is extraneous. 0 is fine here and here. 9 is fine. So these are both fine. So these are the solutions to number 37. Okay, number 8, same type of deal. The arguments should be equal to each other. So n squared minus n should equal 80 minus 3n. Let's see, adding 3n to both sides and subtracting 80 is going to give me n squared plus 2n minus 80 is equal to 0. Okay, so that's going to be n times n. 80, among other things, is 8 times 10. If I have a negative 8 and a positive 10, that will make a middle term of positive 2. So that's going to give me n equals 8 and n equals negative 10. All right, these are the potential solutions, but one or both of them could be extraneous, so we need to check that out. If I substitute 8 in, that's going to be 64 minus 8, that's positive. 3 times 8 is 24. 80 minus 24 is a positive number, so 8 is okay. If I do negative 10 squared is 100, minus 10 is positive. Okay, negative 3 times negative 10 is positive 30, so that's going to be fine. So both of these are solutions. Okay, looking at number 39. Okay, so we need to rewrite this in the other form. So in exponential form, so we start with the base. So this will be 8 to the 4th power is equal to x. And really, we're allowed to just stop right there. All right, that's the answer. Is this on the chart? I wonder. 4,096. So, you know, just for fun, I'm going to write that down. Okay. Similarly, on this one, I'm going to rewrite this in the other form. So this would be 5, you know, to the 1 power is equal to p plus 4. Subtracting 4 from both sides, that gives me p is equal to 1. Checking really quickly to make sure that's not extraneous, that gives me 5, which is fine. So p equals 1 is the solution. Okay, number 41. I've got this 9 to deal with. I think I'm just going to divide both sides by 9 to start off with. So that would give me log base 3 of v minus 10 is equal to 2. So now when I write this in the other form, I get 3 squared equals v minus 10. That's 9 equals v minus 10. Adding 10 to both sides, that gives me v equals 19. Okay, if I substitute 19 minus 10, that's positive, so this is fine. Okay, so solving number 42. Let's not assume that they meant to have parentheses around this. So the only thing, like if you were going to put in parentheses, it could only pertain to the negative 9v part. Let's assume that the negative 8 without parentheses is not included in the argument. Okay, so algebra 1 steps. Our first step will be to add 8 to both sides. So that's going to give us 8 log base 7 of negative 9v is equal to negative 8. More algebra 1 steps. Now I'm going to divide both sides by 8. So divide by 8, divide by 8. So these 8s cancel each other out. And that's going to leave me with log base 7 of negative 9v is equal to negative 1. That's the end of the algebra 1 part. Okay? So now I'm going to switch the form. So this would be, starting with the base, that's going to be 7 to the negative 1 power is equal to negative 9v. All right, that's exponent form. And then I would divide both sides by negative 9. Should I do it like this? Well, maybe I'll maybe I'll fix the whole negative 1 power first. Okay. We all know that 7 to the negative 1 power is 1/7. So this is really 1/7 is equal to negative 9v. So now I'll divide both sides by negative 9. Hey guys, always remember that when you divide a fraction by an additional number, all you have to do is put the number you're dividing by in the denominator along with whatever's there. That's how you divide a fraction by another number. Okay, so this is going to simply be 1 over negative 63. So that should be the answer to number 42. Let me know if it is not what they have on the answer key. Let's solve this logarithmic equation. So first of all, understand that this is in the argument of the log function, so I'd be more comfortable with parentheses around that. Is that how you were interpreting it anyway?
As a part of the
As like within the log?
Yeah.
Okay. So it seems like we should do the product rule and condense these down into a single log. So I could write this as log base 3, and then I'm going to multiply these together as I condense it. So that's going to be log base 3 of negative 15x is equal to 5. Does that make sense so far? So now I'm going to rewrite this in exponent form. So starting with the base, which is 3, then the rest of the problem is going to switch sides. So the 5 is going to come over to the left and make 3 to the 5th power. And then the negative 15x is going to go over to the right. Okay, so now to get x by itself, I'm going to divide both sides by negative 15. So x should equal negative 3 to the 5th power over 15. Now we might leave it like that. What is 3 to the 5th power? Is that on your chart? 243. So we could write this as negative 243 over 15.
Then would you simplify it?
Yes. Both of these are certainly divisible by 3. So what does this reduce down to? Like 81 over 5. I'm pretty sure. So this is the answer.
Number 42.
All right, problem number 44. First, I would do the quotient rule. So I could rewrite this as log base 9 of, and so when it's subtraction, it condenses down to a division problem. So this is going to be x over x minus 4, and this equals 1. Now it's time to rewrite this in exponential form. So I'm going to start with the base, and then everything else is going to switch sides. The 1 is going to come over here as the exponent, and the fraction is going to come to the other side, x over x minus 4. Now, of course, 9 to the 1 power is just 9. So I'm going to immediately erase this 1. So it's just a matter of solving this equation. So I would go ahead and multiply both sides by x minus 4, all right, to cancel out the denominator. So the x minus 4s cancel out. So now I have 9 times x minus 4, which is 9x minus 36, is equal to x. So I think I will subtract 9x from both sides, all right, just to avoid getting 0 over here. So I'll have negative 36 is equal to negative 8x. And then I would divide both sides by negative 8. All right, to cancel these out. This is going to be positive stuff. This is going to reduce down to, okay, both of these are divisible by 4. So this is going to be 9 over 2. And that is the final answer. Okay, take a look at problem number 45. First thing you want to do is the product rule. These will condense down to a single log using multiplication. So I'm going to do x times x plus 4. So that's going to be x squared plus 4x. And that will equal 1. So now it's time to change the form. So I'm going to have 5. And the 1 will come over here, and the x squared plus 4x will go over there. Of course, the 1 power is not changing anything. So that's just a 5. So let's go ahead and subtract 5 from both sides. So we will have 0 is equal to x squared plus 4x minus 5. So hopefully this is factorable. So this is going to be x and x. 5 can only factor as 1 times 5. And we're going to need a positive 5 and a negative 1. All right, now setting these factors equal to 0, so x minus 1 equals 0, x plus 5 equals 0. That's going to give us x equals 1 and x equals negative 5. Now we need to check for extraneous solutions. You can't take the log of a negative number. So you have to plug it back in. Don't just assume that because it's negative, it's automatically extraneous. You have to plug it back into the original problem and see if you get a negative then. Even if I plug it in right here, when I have this 4 kind of balancing things out, still, negative 5 plus 4 is negative 1, so that's no good. So of course it automatically fails here. Wait, you can't see all that. If I put in negative 5 right here, I have the log of a negative number. So then the negative 5 is extraneous. Got to throw that out. But 1 is fine. If I substitute in 1 in either position, that's going to be a positive result. So I'm only going to have one solution to problem number 45. X equals 1. All right, so for number 46, when you have 2 logs that are being subtracted, you can condense those down to a quotient. So it's going to condense to division. So this is going to be the same thing as the log of x minus 4 over x. All right, and that equals the log of 79. So now I just have a log equal to a log, so the argument should be equal. So that means that x minus 4 over over x should equal 79. Multiplying both sides by x, maybe I'll just go ahead and show it. Alright, so those will cancel each other out. So that's going to give me x minus 4 is equal to 79x. So now I'm just going to subtract x from both sides. So that's going to give me negative 4 is equal to 78x. And then if I just divide both sides by 78, that's going to give me negative 4 over 78 is equal to x. And then it's just a matter of reducing this. Okay, so this would be the final answer. X equals negative 2 over 39. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.